we can start. Today, I want to talk about ice caves in Tatra Mountains in Poland. But first, you can switch to the next slide, Johnny. Okay, but first let's define what an ice cave actually is. So ice caves is a cave with permanent ice or snow. But one of the fundamental questions concerns the genesis of perennial ice masses in caves and their stability under model climatic conditions. Okay, next. Ice can accumulate in caves or their parts only when the inside temperature drops below zero, at least for some part of the year. And this conditions is met in some Tatra caves. However, the circulation of air inside a particular cave, which is strictly associated with cave topography, as well as outside climatic conditions are crucial importance for the existence of permanent caves, permanent ice in cave. Two microclimatic types of caves occur in Tatra Mountains. Static caves and dynamic caves. Static caves are located above 1,500 meters in Tatra Mountains. That is in the climatic zone where the mean annual temperature falls below 2 degrees. Perennial ice is also found in some parts of Tatra caves that display dynamic or air circulation resulting from the chimney effect. Cold, dense winter air is sucked in through the lower entrance, whereas less dense, warmer air escapes through the upper entrance. This mechanism causes effective freezing of cave sections, even several dozen meters in length near the lowermost entrance for these caves. The circulation is reserved in summer. A lower entrance emits air that is colder than atmospheric air. However, in favorable conditions, that accumulated ice does not melt away completely before the next winter. Okay, next. John. So 43 ice caves are listed as being in Polish part of Tatra Mountains. All the caves where perennial ice was detected in final years of the 20th century are regarded as ice caves. Through many of them is lack ice presently. Many of them are small voids that can be classified as a shelter. Some small caves with conglomeration ice or recrystallized snow were reported only once in summer or autumn season are not included because the occurrence was likely only incidental. Okay, next. The only cave where ice and temperature measurements were carried out in Polish Tatras is the ice cave in Ciemniak. Next. Ice cave in Ciemniak is located in Western Tatra Mountains, and it hosts the largest known block of the perennial ice in Poland. Next. Its entrance is situated on 1,750 meters above sea level, about 600 meters above the floor of Kościeliska Woli. Next. The cave has one entrance exposed to the west, and the total length of these passages is about 390 meters. Next. This cave was described for the first time in 19th century by Pawlikowski. Measurements and research started when the cave was rediscovered by Tadeusz and Stefan Zwoliński in 1922. The next measurements and research were carried out irregularly in 60s, 80s, and 90s, and at the beginning of the 21st century. The latest measurements are from last year. Next. The cave climate is classified as dynamic and is characteristic by strong air circulations. The cave entrance can be seasonally blocked by snow, which change the air circulation inside the cave. Next. So the perennial ice body has stratified structure consisting of alternating layers of cleaning ice and ice with rock and dust and some organic detritus. Seasonal forms of ice accumulation develop as ice stalactites and stalagmites, as well as in form of ice falls on the cave walls. Next. Oh. Yeah, that. Cave air temperature was measured by for the 10 months in the entrance and in the middle part of the cave. Comparative analysis of the air temperatures records in the cave and on Karst reveals three kinds of relationships. In winter, when air temperatures outside and inside cave were below 0 degrees, the fluctuations were almost simultaneous. The temperatures of cave air were higher, but they will reflect changes observed on the surface. Yes, but during the late winter and spring, the situations change. The temperatures outside the cave fluctuated around 0 degrees, and one time were higher and another lower than cave air temperatures. The variations were still well recorded in the air cave temperatures, but only for temperatures below 0 degrees. For periods where temperature outside the cave were positive, the cave air temperature was stable at few degrees below 0. Yeah, and in late spring and summer, the temperatures outside the cave were positive. They were accompanied by a stable temperatures about 0.1 degrees inside the cave. The changes in the surface temperatures had no reply in cave air temperatures, which was controlled by latent heat balance driven by mating process. Summer circulation conditions starting in late June or July and cold cave air gravitationally drained out through the entrance, whereas the warmer external air is sucked from the surface by the chimney effect. Okay, next. And measurements of the loss of ice in the cave were also carried out on the basis of the fixed points mounted on the walls in the 2000 years. There has been a huge loss of ice in the last 20 years. Today, permanent ice is presented only at 2 measurement points. Next. The increase in negative ice mass balance is probably a reflection of an increase in mean annual temperatures. Moreover, the trend of degradation of the ice mass follows the global trend of ice cave mass degradation and may lead to the ultimate loss of perennial ice mass cover in the cave during the following decades. Next. A photo taken by the first discoverers of the cave, the Zwoliński brothers, was compared with a photo taken today to show how much ice has melted in the cave over the last 100 years. Okay, next. But at the end of the 19th, the situation was not so bad. Next. But currently, the repair anchor visible on the previous photo now is about 4 meters above ground. You can see it on here in the red point. Okay, next. The phenomenon of ice disappearance is observed in all ice caves in Tatra Mountains. In this photo, we can see Wielka Śnieżna Cave and market repair anchor inaccessible by icefall mating. Okay, next. Ice mass losses were significantly higher in the last decade in comparison to earlier periods. So the perennial ice mass is not stable in modern climatic conditions. And we think if this trend continues, ice cave will no longer be present in Tatra Mountains. So thank you for your attention. Maybe Johnny, you want to say something more about this?
So maybe I just want you to take a look again on this picture, because here we can clearly see the this loss of the ice, as you can see from different horizons, from 100 years ago, exactly 100 years ago, how did it look like in this big corridor. As you can see, it was almost 10 meters of ice in comparison to nowadays. And nowadays, last year, when we was making the last survey, as you can see, only here and here, there is a piece of ice in this part of cave. So the loss is very, very big. And I think that just in near future, it will totally disappear in this part of the cave. And maybe the last thing that I would like to add is that through this 100 years of since the cave was rediscovered, not only ice was the object of investigation, but also fauna, microflora, microfauna, heavy metals, and so on. So there was like dozens of research made in this cave. Okay. If you have any questions, feel free to ask us. will try to answer.
Thank you for that presentation. We do have some questions coming in on the chat. One person, Nicolina, asked, do you have long-term measurements of temperature and precipitation in the Tatra Mountains?
Excuse me, I'll try to answer. Yes, we have, but I'm not sure what what is a long period for the person that asked the question. But I would say that for last 50 years we have continuous record of precipitation and temperature. Of course, not in the cave or near the cave, but in the one of the meteorological station at the top of a mountain in this part of the range.
The comment is 50 years is a lot. And do you connect the loss of ice, obviously to the rise of air temperature or loss in precipitation? So is it because it's getting warmer, the ice is melting, or are we just not having the precipitation?
In fact, the first explorers of the caves, the Zwoliński brothers, when they rediscovered the cave in 100 years ago, when they came there after 10 years in 1930, in fact in 8 years, they then noticed the loss of the ice, and then they made a note that probably it is because of global change. So they were really aware of the fact of climate change, and they even confirmed it in 1950s when the loss was much bigger than after these 8 years. And there was one article that used meteorological data and compared it to the ice loss in this cave. It was published in 2004 by Rachlewicz and Szczeciński, and of course there is a correlation with climate change.
Thank you. The other question we have, and I think this is of interest to a lot of us, and whether we have ice caves or not, is are you using this data or this information to promote any actions, climate change actions within the park or the Biosphere Reserve as well, and that you have this, very dramatic, pictures and data? Is that inciting any movement or management decisions?
Fortunately or unfortunately, this cave is located in the protected area. So as far as I know, any acts of, I would say, environmental engineering are impossible in this area. But I think that we have here a person who works, maybe not, for the Tatra National Park. No, I don't see her on the participant list. Yeah, but I think it's as far as I know, there was no any action that tried to stop that, and as far as I know, it's impossible according to our restrictions.
Of course. Might you be using it in any kind of, education or outreach to, say, the public or others to promote, more sustainable choices, I guess, is maybe a better way to phrase. I think what Daria's question is, saying, hey, the ice is melting, what do we do, to stop this? Yeah, we're talking about this one particular issue, but are there things, we could be doing across the world? I mean, I know that's a big, broad question, or within our biosphere, or within our parks, to promote, more sustainable actions, like within, us, within our governments, within our, protection of our water resources. So kind of at all those scales. So I understand that, one particular thing is, not something you can necessarily stop, is what I'm saying. But maybe if we're using this for promotion and outreach, if you guys have any comments on, perceptions outside of our scientific community.
I just add one thing on this topic, because in fact, there was one action that tried to prevent the ice from melting, maybe not in this ice cave in Polish Tatra Mountains, but another ice cave in this range. And some cavers tried to block the entrance during the winter. So there was no connection between the atmosphere outside and inside the cave. But it was just for a couple of years. And in fact, they noticed that the ice stopped melting, or maybe the dynamics of this of this phenomena a bit decreased, but it was not it was not an initiative of a national park, but some cavers. So yeah.
Do we have questions or comments from anyone else that may be working on similar, climate change issues, or that want to share what they're doing in their biosphere reserve or protected area? Or even comment, are since you guys are from the university and really just particularly focused on the research, how does the interaction with the Biosphere Reserve work, or with the national park there as well? How is that relationship developed? I think that was one more question for our speakers in the chat, was, if you're researchers, how do you collaborate with the park and the biosphere?
So we if we want to do any research in this area, we have to have permission from some park, and they allow us, of course, if we met the expectations and requirements, we may enter. Of course, we may first of all enter the cave, because it is not allowed to do that without permission. So I would say that there is a good relation between scientists and national park. However, I think that there's another maybe problem I think it is a global problem, that cavers that are not scientists, maybe they are not always aware of how this ecosystem is fragile, and that just the appearance that can disturb the conditions inside the cave. And I think here we should, together with the society, caving society, and national park, we have to do something to increase the awareness.
Agreed. And that's why I think the UN's this is all tied with both, caves, but also groundwater. And I think, that was a great theme for our International Year of Groundwater, was making the invisible visible, because a lot of times, like you said, this isn't a protected area. Only very few cavers and researchers, are actually getting to see these amazing resources and how quickly they're disappearing. And so I think you have a very, very good, example of why we need to take some actions, right? It's just like when you can see that's where we used to repel or abseil from, those types of things. That's very visual, and people can connect with that. And so I think that is something that, unfortunately, you have this very, good example of, hey, this is what's happening. and we need to make some sort of decisions to, more broadly for climate change. Great. Well, again, I want to thank our presenters, our speakers today for sharing this special case in Tatra. And do we have any other questions or comments this morning? Well, if not, I will say, okay, go ahead.
Okay, just maybe one thing. So maybe if you see any of the participants see any space for collaboration, we are open, and that's the thing that I would like to tell you.
Yeah, I think this is wonderful. This was also one of our goals of this webinar. I'm Daria. I'm also one of the coordinators of the CaveMAB network. And we really want to promote the collaboration of Biosphere Reserves partners to have some kind of joint activities. So this is very welcomed, your initiative, and I just wanted to maybe make a kind of final remark from myself. It's like from this thing that we heard today, it's really obvious how fragile not only our karst areas and caves are, but actually the whole planet.
Well, I'm not hearing anything else from any of our participants here on that. I think in general, like for the CaveMAB network, we are very much interested or exploring different ways that we can collaborate. And I think one way that's, this webinar is representative of is, again, and like I said, you have this very very clear, picture of what's happening in a way to promote the whole, what we're trying to do, which is conservation and more sustainable decisions in everything that we do and as humans. So Clayton, did you have some parting comments?
It's just to thanks for the presentation of this. I think it's very important issues for us, because it's a way to show clearly the connections between the science and the management of areas and the climate change we are living. It's easy to show people and to use this as educational material. And then next year we think also to organize a webinar on tourism in caves. And then we had in this webinar information about biodiversity, hydrology, climate change, and culture. And then I think these examples will be very important to discuss well how to use not in only in touristic way the caves, but in educational way all this information. No, I think we can collaborate to to show this very nice examples that we have uh, with other biosphere reserves and to use this as a publication, sites, material to prepare something. And then, well, I love it, this information that you have, and 50 years of data is not easy to to get continuously. And then, parabéns, welcome. Thanks.
Thank you again, everyone. Really appreciate it. Please stay in touch. We're going to have an open access publication from several abstracts, and we only selected 4 for the webinar, but we received several, and so we'll be in touch with everyone that submitted those as well. And again, just keep celebrating and promote the International Year Together for Caves and Biosphere Reserves and the UN Year of Groundwater, and reach out to as many people as you can to get Caves and Karst and Biosphere Reserves on their mind and important, and connect them to their lives and to nature. So thanks again. I appreciate this very much, and take care.